Welcome to my 2D mining Sandbox Godot community project tutorial. I built a framework for a 2D mining game that has very little content as it is, since I want you to add to it. I'm not looking for unpaid laborers to make my game for me. This isn't supposed to be a game, and I'm certainly not intending to sell it. This is meant to be a learning exercise for you. If you have trouble getting started in Godot, don't have any ideas what game to make, are overwhelmed by creating an entire game yourself, are lacking motivation to work on something all on your own, are looking to test your hard-learned skills on something real, or want to learn about structured team coding practices, you are in the right place. Even artists or sound designers with no coding skills can contribute. This game was originally meant as a tiny demo to show some good Godot practices and advanced techniques when designing a Godot project. Since then it has become much more. Now it's a very flexible framework that is easy to mod and build upon. It currently features an infinite terrain generator, building, crafting, combat and mining mechanics, a mob spawner, fluid simulation and a lot more little things. You can very easily add custom blocks, items, game modes, machines, mobs and so on while learning how to Godot in a professional manner. To contribute to this project, you will need to sign up for a GitHub account. Most of you will probably be familiar with this website already. Almost everybody who's serious about coding has an account here, and it's incredibly useful. I created a new account so everything should look as it does for you if you are a first-timer. You can ignore everything on the front page and just move along to the link below. This is the game's main page. Make sure the branch selected is the latest branch, which should be selected by default. It will contain all the latest patches and hotfixes and content. Now we are going to fork this code repository by clicking Fork. This will create a local copy on your GitHub account, which you will be then able to modify. We are not changing anything here, it's all on default. Now this can take a few seconds. Let's see. And here we go. Now to interact with our new code repository, we will use the software GitHub Desktop. It is free and available for Windows, Mac OS and should be available for Linux too. When you press Sign in to GitHub, it will redirect you to the website and will ask you to authorize this access. Again, no need for you to change anything. You have to do this one time or allow it to always do that. It really doesn't matter. Now it asks you for your sign-in credentials. These are the same that you logged in with to GitHub, so you can just go on. Now you need to clone your web repository to your local hard disk, so we can start Godot on the local project. I won't be changing the default directory, but you want probably to put it where you have all your Godot projects stored. Takes a second to synchronize, and now it's downloaded. Here we want to choose the first option to contribute to the parent project. Yes, continue. I like to press refresh, or it says fetch origin, again to make sure everything is downloaded. That was a lot of mirroring and cloning, but now we can finally access the project on our local machine. Press scan and select the directory your put the project in. Double click and here we go. The current version will spam some errors when you first load it, but that's not a problem. You can just go to project and reload current project. And on the second run, it will be clean. This might not be necessary if you pick up a patched version of this that I will make in the future. If you run the game, you see a free player skill selected, the only available character, El Clásico, and when you press play, you can explore the game. The controls are currently only listed on the GitHub page. Next up, we will start adding content. So we'll be adding gold to the game, a gold block and a gold ore item that is dropped by a gold block. You can see pretty much everything is stored in the game directory. We want to navigate to blocks and then create a new folder called gold block. Or do we? Yes, we do. What am I doing? I don't know. This block will be very similar to the already existing iron block, so we can take a lot from this. But first we create a new resource in our gold block folder, look for block and create. Name it gold_block. There it is in our folder, and you can already see it on the right side in the inspector. Now we will change some minor settings. Just let you take a look through it. We can also compare it to the iron block. The iron block has a texture, of course. It drops iron ore, which is an item. It is located at this path, but we don't need to worry about it now. The block has a hardness. It's how fast you'll be able to mine it with your pickaxe. It has a tag. Tags are like groups. It has a particle color. The particle it will spawn when it's broken. And it has an internal name. Down there it's iron. Let's go back to the gold block. Okay, we will take care of the texture in a minute. But first we will set the hardness. It's not as hard as iron, but harder than the default stone. Set it to 1. Now add a tag. Oh, I guess particles first. Sorry, I'm just doing voiceover to my previous recorded video, so I have no idea what this guy's doing. Yeah, make it golden. Now we add a tag. And there's nothing in the quick load, but we can browse to tags and see what we already have. Ore blocks, that's the tag we want. I will come back to how and why to use tags later. We leave the material as rock. That's mainly about the sound it makes. And now we should create a texture. I'm using a software called Paint.net, but you can basically use any software that's capable of saving PNG files. Now I will open the already created iron block texture and just make the iron spots a little bit more golden. Now we are going to save this in the gold block folder. We just call it gold, and it will be a PNG by default. Back to the editor, and we can just drag and drop this gold PNG onto our texture property for a gold block resource. That was step 1. Now, to see the gold block in action, we will create a scenario. Find base scenario tscn, the base scenario scene, and create a new inherited scene. This isn't really necessary, but we can rename the root node to test scenario. So looking at the editor, we will always know where we are. We will save this scene to the local folder. This folder will not be synchronized with our online repository. More on that later. Now we will use the level editor to paint a gold block. But first we need to run the game once to make sure the gold block is recognized, because it was just created and the level editor doesn't know about it. It may spam some errors, but these aren't critical and can be ignored. Now back to our level editor tilemap. Click the level editor and tilemap down below, and now we can find the gold ore block. The player will spawn here at the origin, so we will place some gold blocks further below, like so. Now when we try to run this scene like this, it won't work. Actually, in the newest version it will work, but I will show you anyway what happened here. It stops because it can't find the game settings. We haven't set them. Scenarios come with a few settings out of the box already. We uncheck has timer because this isn't a timed scenario. Create new game settings. We don't need to change anything in here for now. It's just the settings we needed to create, the resource. There is another setting we missed. When we run again, it will produce an error because it can't find a player scene. It can't find a character to spawn. This will be also patched in the newest version, so you don't have to set it manually. It will try to get the first character it can find and spawn it. For now the only character is El Clásico. Put the El Clásico scene in here and run it. Here we go. Now if we mine the gold, you will see it drops nothing because we haven't created gold ore yet. So let's browse through the items folder. We can use the iron ore as a template for what we are going to do. Let's create a new folder called gold ore. There you are. Create a new resource of type item. We call it gold_ore. You can see it in the inspector. It needs a texture, first of all. We can use the iron ore texture as a template, or deal with the text first, whatever you want. Okay, it has an ores tag. Let's apply it here too. Tags, add element, and then drag and drop from the text folder. From the text folder, thank you. Let's add a name too. I'm switching over to Paint and loading the iron ore. Do a little bit of magic to make it look like gold ore, and then save it in the gold ore folder as gold PNG. Back in the editor, I will drag and drop the gold PNG texture on our gold ore resource texture, and then navigate to the gold block, go to the drop, quick load, find the gold ore item here, and it's done. We have successfully created a gold block that drops gold ore when it's mined. and we'll pick it up in our inventory. Now we want to upload these changes we made. Switch over to the GitHub desktop app and it will show you each file you modified. There may be files in there that you didn't intend to modify. I, for example, accidentally changed the game manager when I was recording the video. You haven't seen that in the video I'm showing you. But this change I want to discard. This has nothing to do with our gold blocks. Discard changes. Discard changes. Even the iron block has apparently some changes. I may have changed some property accidentally, so we will also discard all changes on the iron block. Again, this has nothing to do with our added gold block and gold ore features, so we don't want to have this in our upload. We could have also just unchecked the blue checkbox to exclude these files from our upload. By discarding the changes, though, we reset those files to the state they've been before. Now let's commit our changes. A commit can contain changes to a single or multiple files and always has a name and an optional description. We will now make this commit to our local repository. Note that the act of committing doesn't change any files. It simply tells our repository that we bundled and finalized all the changes we made under this one commit. We also could have made two commits here. One commit bundling all the changes to the gold block and one bundling all the changes to the gold ore. Now let's push these changes to our online repository. By pressing Push Origin. You may have noticed a little number 2 next to the upward pointing arrow in the video right now. That was due to a mistake I made while recording, so you should have had a 1 up there. It finished uploading, and now we can go to the browser and check out our online repository. Press refresh so it will show our recent changes, and right there it will tell us that we made commits to this repository. We are ahead of the original project, meaning we have changes that the original project doesn't have yet. Clicking this link will take us to a pull request. A pull request is the final step we make when contributing to a project. So we made changes in Godot in the editor and added the stuff we wanted. Then we made a commit on our local machine. Then we pushed that commit to our online repository, and now with this pull request we are suggesting that these changes should be included in the original project. Or in technical language, we create a pull request that will merge our commit into the original project. Scrolling down, we can look at all the changes we made to the original project. Green means it's stuff that we added. Red would mean it's stuff that we removed. This will make more sense when looking at script files with actual code. These are Godot resource files that aren't very readable. So if you are a beginner, you probably won't gain any insights from looking at this particular commit. Don't worry if you don't understand these lines. Now let's create the pull request. I have already entered a title and a description. This is what will be presented to the original project maintainer, which is me. We are basically saying, yo, I added this feature. Please make it part of your project. I will be informed immediately by receiving an email. And then I will decide if I want to merge this into the main project. Let's finalize our pull request by clicking Create Pull Request. Throughout this process, we will get feedback telling us if there are any conflicts detected with this merge. This isn't something you need to worry about. When it says no conflicts, it means I can just one-click merge this into the project. If there are conflicts, it usually means you and other people made changes to the same file. And I will have to figure out how to consolidate these changes into a final version. By the way, we are currently looking at the pull request on the original project's website. Everyone will be able to see your pull request, to review the changes you made or comment on it. More complex changes will usually be reviewed by multiple users. Adding a simple new block or a new item isn't too complex though. I can simply run this version of the game with the changes you proposed and check out if everything works. Then I will merge and close this pull request, so it's part of the latest branch of the original project now. I've tried to keep this as simple as possible, with as few steps as possible. But there is a more proper way of doing this, with an additional step in between. What we actually want to do is keep our fork of the latest branch clean, meaning we don't want to make any changes to it directly. That's why we want to create a new branch for our gold update. Click New Branch and enter the name Gold. It will be a clone of the latest branch. So the latest branch can stay untouched and all the changes will be made in the gold branch. Back in the GitHub desktop app, we want to switch to the gold branch. If it doesn't show up here, we need to refresh the repository because we just added the branch and the local repository might not be aware of it. There it is. The app is really smart because it's asking us if we want to take our changes over to the gold branch. And that's what we are going to do. With the gold branch selected, we now commit our changes. Everything from here on is exactly the same as before, but it's done on the gold branch instead of the latest branch. We will push our commits to the online repository. There we will switch to the gold branch. We can see that it's now one commit ahead of the original branch. Now we create a pull request to be merged into the original project's latest branch. At this point we are done with the gold branch. We won't be touching it again. Still, we are not going to delete it from our repository since it is part of our pull request. So there aren't any further actions you have to take. Next up, we'll be adding a new character to the game. This time we will be starting by creating a new branch immediately. We'll be calling it Mining Drone because the character we'll be adding is a drone. After creating the new branch, we switch back to our GitHub desktop app and select the newly created branch. If it isn't in the list yet, refresh the repository. Here we go. When switching branches, I like to make sure to have the Godot editor closed, because I don't want Godot to get confused when we are updating or removing project files while the editor is open. although it can deal with it, I don't want to risk anything going wrong. Well, it still is a little confused. We can see the error message down there. It was trying to reopen the gold block resource, but that's gone. It only exists on the gold branch, and we are on a brand new branch. Our branch is a clean clone of the latest branch of the original project, which doesn't contain the gold update yet. This isn't a critical error though, and we can just go on with our life as if nothing happened. To create a new character, we have to locate the player scene, or to be specific, the base player scene. I call it base because it can't do anything on its own. It needs to be inherited, so we create a new inherited scene from the base player scene. You can see it already contains a lot of nodes. We can see a visual representation of its collision shape, and the yellowish shape is an interaction area. We'll be changing or moving these shapes later on, but first let's create our visual representation of the drone. I will create a node 2D under the body node. I'm calling it visual. I won't be using textures or sprites, but be working with polygon nodes. This is easier for me because I'm not an artist and can't make any pixel art. I'll keep the original collision shape visible so I have an idea of the size of our character. We should save our scene. We save it to the Game Player Characters folder. Here we create a new one called Mining Drone, and in that we will create a mining drone scene. I will also create a rotor scene purely for visual purposes. I will add a little script that makes the rotor look like it's moving, but that's not of importance here. Now that I'm done, I will start the game. And already we can see that the mining drone is a new available character. But when I start it, it's gonna throw an error. We will have to set up a few node references in our mining drone scene. The body node already exists and we just drag and drop them where it says body. The interaction area also exists and we can drag and drop it right here. This is a good time to see if our interaction area and collision shape match. Its default position is a little too close to the center of the drone. I want to interact with machines further out. The original collision shape doesn't match at all. Before changing it, I'm gonna make it unique to make sure I'm not messing with the original collision shape, because Godot is sharing these shape resources by default. This new shape should be a close enough representation. Now back to adding the rest of the missing nodes. We need to add a pivot node of type node 2D. In a conventional character, this would be the shoulder. It's the pivot point of where your item you're holding in your hand is rotating around. For the purposes of this tutorial, I will create a shoulder and a hand on my mining drone, although that doesn't really make a lot of sense if you really think about it, but these are required nodes. So I'm adding another required node. It's a hand node, also of type node 2D, and offset it from the shoulder. So when I rotate the shoulder, the hand rotates with it, but is a bit further away. Now we can drag and drop these newly created nodes to the respective inspector fields. Note that it doesn't let me drop my hand node on the main hand field. This is because it's looking for a hand script that needs to be attached to the hand node. After attaching our script, we can see that the hand now requires a reference to our player scene. So we assign the mining drone here. Then we go back to the mining drone and assign our hand. These references are necessary for the internal scripts to work properly. I'll be fast forwarding through this part of the recording because what I had to do here isn't necessary anymore. Now we can play the game, but the mining drone just drops down and is laying on the floor. Everything else is working though, but we need to tell the game that this isn't a simple platformer character, but a flying machine. And then the game crashed with an error that tells us that we need to override a method in our custom character class. Well, we haven't even created a custom script for our character yet. To add a custom script, we first have to detach the default base player script and then attach a new script. Let's get rid of this pre-generated template code. Our character scripts need to extend the base player script. To get an idea of what such a custom player script should look like, we can switch over to the other custom player script from the built-in character El Clásico. For now, we don't care what is in there. We just want to make sure we are copying over this one critical method, because not having it in a custom player script will cause the game to crash. We copy it to our custom script, but leave it empty for now. Now the game should work without crashes when using our mining drone as character. Well, not quite, because we removed the base player script and reattached a new script, all our node references are gone. So we have to drag and drop them in here again. And make sure to press all the refresh buttons to restore the values of these empty fields. Now the drone works without crashing at least, but the pickaxe will not play a mining animation and the sword will not play a stabbing animation. That stuff we will have to add. But first let's take care of our drone movement. We can find the built-in movement script in our base player script. In line 108 and line 109 you can see it already has a fly mode. But it will only work if the fly cheat is enabled. But for our drone we want to fly all the time, so we override the movement method and just reroute it to fly. We can already test it and see that we are not prone to falling and hover along in the air as if we are a drone. The only thing missing now are the animations for the pickaxe when we are mining and for the sword when we are stabbing. We can look at the El Clásico character script to see how the incoming actions are processed by the animation player of El Clásico. The animation player is not part of the base player scene we inherited from, and needs to be added manually to our mining drone. So after I copied over the methods onHand action and onHand action finished from the El Clásico script, we still need to add an animation player node to our mining drone and create a variable for it. If we open the El Clásico character scene, we can select the animation player for its hands and look through all the animations that it covers. It has mine, stab, swing and throw. For this demo we will only implement mine and stab. Back in our mining script we will drag and drop the animation player node into our script, holding Ctrl to create a variable reference to that node. Now let's add the animations to our player. The first animation will be the mine animation. I won't go into detail about how to use the animation player. There are enough tutorials for that. I'm setting it up so that the hand node moves back and forth. But when we run the scene, we will realize that this still isn't working for some reason. The pickaxe isn't moving at all. We missed a method from the El Clasico script. There are two special methods, onStartMining and onStopMining. We need these in our custom character script too, and let them trigger the mine and the reset animation. That's all. Now you can see our mining animation is working. It's very ugly, but it's working. When I switch to the sword though and press attack, nothing is happening because we haven't included a stab animation yet. The debugger will even let us know about it. On hand action, animation not found, stab. The stab animation should be easy enough. It's just our hand going forward and then back. But there is one more important thing to these melee attacks. Let's inspect the stab animation in the El Clasico character. It contains function calls to set an attack state. This is important because we don't want our sword to always deal damage. It should only deal damage when it's extended, not when someone is running into it or when we are just starting to stab. So these function calls will enable and disable the attack state of something we are carrying in our hand. We need to add a call method track to our stab animation and select our hand. Insert key and choose the set attack state method. By default, the parameter is set to false. Click the key and then change the parameter to true. You can find it under args. Now we'll insert this method the second time at the end of our animation, and this time leave the parameter as false. There is one more thing we have to take care of. The built-in player script has no idea how long this stab animation we just defined is taking. And we have to let it know about it, so it can decide when it's possible to start a new action. Usually it will tell us when to stop an action with on-hand action finished, for example when the player stops mining. But here in the El Clasico script you can see how it's working the other way around. The built-in subscribe hand action finished method allows us to trigger a callback to the built-in script when our hand animation is finished. Again, this will only be necessary for a custom length action like stabbing. Mining, which runs in a loop, is not affected by this. The built-in script is sending us a callable as parameter to this method. And we make sure this callable is called by our animation player when it finishes its animation. This is probably the least intuitive part of our custom character script, but I needed it to be this way to be as flexible as possible. Now that we've finished up our attack logic and the step animation is working, we need to find a bat to try out a sword. Here it is. Ha! This concludes the custom character tutorial. It just took us about 15 lines of code, setting up an animation and assigning a few nodes to our base scene. Now we can commit these changes to our mining drone branch. Push these changes to our online repository, select the branch, and create a pull request from it, in order to propose the addition of a mining drone character to the original project. Next up, we will create an ore detector as a hand item. Create a new branch, let's call it ore detector. Refresh our local repository so the branch is shown in the list. Select the branch, and I like to refresh again, but I don't think it's really necessary. Let's browse to Game, Items, and create a new folder called Ore Detector. In which we will create a new resource of type hand item, also called Ore Detector. Let's set some properties in our Ore Detector resource. Make it of type custom, since none of the other types really apply. Set material to metal, although this won't have any effect currently. Disable inventory stacking and give it a name, Ore Detector. We will take care of the texture later. Now let's create the item scene. This is the actual object we'll be holding in our hand. Its root node is going to be a 2D scene or 2D node. And again, it's called Ore Detector. I like to add a space here, but this has no effect on anything. Finally, attach a new script. We can go with the default name here. This script is going to extend the hand item object type. A hand item object will be the actual object in the game that our character is holding in his hand. A hand item is a resource. It defines the type of our hand item object. Hand item objects already have some built-in logic, as almost all my scripts do. Before writing the script, we will take care of the visual representation of our item detector. Again, I will be using the polygon node. The detector has a little light on top that can change color. It has an on and an off color depending on if it found an ore underneath. Let's write the actual detection code. First, we need a reference to our world object, so we can scan for blocks on our tile map. The hand item object class contains a method with which we can access our player called getPlayer, and the player in turn has a method called getWorld to access the world. Now we can use the world object to access a block at a given position. This requires us to pass the cell or tile position. But our object, the ore detector, is a node 2D, which only has a global position. You could call it a pixel position. To convert it to the map position, we call world local to map and pass our global position, and this will return the cell or tile position to be passed to the getBlock method. Let's reorganize this a bit, because we don't only want to scan on one position, but on multiple positions in a line below our ore detector. Let's say from one position below to 10 positions below, or one cell below to 10 cells below. Here we can make use of the tag called OR blocks. Similar to groups in Godot, we can use this to check if the block we detected is in a group or has a given tag. Each time we add a new OR block to our game, we gotta make sure to add this tag to the block resource. Hashtag requires us to pass a string. This is called hard coding and isn't really a good practice. I'm doing it anyway because I haven't found a better solution for this yet. So we copy the name of the OR blocks tag resource and paste it in here. If the detector finds such a tag on any block in the line below, we will set a variable called foundOr to true. And we can break from our for loop because we don't need to detect any more ORs below that if we already found one. Next, we will need to change our lamp color accordingly. It's a polygon 2D node, so it has a color property already. I can write this logic in only one line using a so-called ternary operator. It will make sense once you see the line finished. Of course, we can also write this in multiple lines using an if-else block, but this is more compact. I already set our export variables on and off color to the according colors for lamp on and lamp off. We are finished with our hand item scene now and are returning to our hand item resource. Here we need to reference the just created scene so the resource knows which scene to instantiate once we equip this item. This is a very important design choice, to keep apart resources and scenes. Resources contain static data like the item type or the texture it has when put in the inventory. If you put this data into the scene object, you will have to instantiate that scene to access its data. That's a common beginner mistake or bad design choice. The only thing missing now is the texture for our item. It's the picture that's displayed in the inventory or hotbar slot. It's a 16 pixel sized PNG file. Drag and drop it onto the texture field, and now we can run our game and test our OR detector. But wait, we don't have the OR detector in our inventory. We need to add the OR detector to our default player loadout. Let's move to the free play scene for our free play game mode. In the game settings, it defines the player loadout. Here it's empty, which means it will default to the character's loadout. So we move to the El Clasico character and check his loadout settings. Finally, we found our default loadout. It already contains 2 inventory items, the pickaxe and a sword. Now let's add a new inventory item. It's going to be empty at first, select new inventory item, and now we are quick loading our OR detector resource in there. We could have also dragged and dropped it from the file system. Let's try this out. Whoa, it's huge. And a crash. It says non-existent function hashtag in base nil. So we were trying to get a tag of a block that doesn't exist. We were checking all the cells below our OR detector. Some of these cells, and probably the first cell always, below our detector may be empty, so there is no block. We have to make sure there is a block first before running our hashtag function on a block. So let's reorganize this quickly. because we will need to use this position multiple times now, we'll give it its own variable, then insert it here where it was before, and add a condition. We will check if there is air at the position first, and if there isn't any air, then we can run the second check too. This will make sure the second check never checks on an empty block and thus can't crash anymore. Here we go. Now everything is fixed. It should be working as expected. It's still a bit huge, but it successfully detects ores underneath and lights up accordingly. And again, with very little effort, we added a new feature to our game. And as usual, we commit our changes and create a pull request. There is one important thing to note here. Because we made changes to the default loadout, it shows up in our commit as well. But with our pull request, we only want to suggest to add this ore detector item to the game. We don't want to also suggest to change the default loadout of the player. This should be up to the original project maintainer to do. Or if we did it, we would do so in a separate pull request and not bundle it with this feature addition. It's like asking, do you want cake? And as soon as the person answers yes, you say, and you have to eat it all now. We want the project maintainer to accept our cake, so we shouldn't attach any additional conditions to it. Let's create a jump pad. Create a new branch, switch to that branch in your local repository, and start the Godot editor. The jump pad will be a block entity, like our furnace. Block entities are advanced devices or machines that can be handled by a simple custom block. They can also be bigger than one block. Let's inherit a new scene from the base block entity scene. I'm changing the root node name to jump pad. Then I'm gonna add a new folder under game block entities where our furnace already exists. Create the folder jump pad, and in there we want to create a new resource of type block entity definition. Like in the previous chapter with our hand item and hand item object, we again differentiate between resources and scenes. The block entity definition resource contains data like the size of the object and the ingredients it takes to build it. While the scene we just created and have to drag and drop into the resource as a reference will contain the visual part of our block entity and the logic. Actually, we don't want to register tick, and I disabled it again off camera later on. We won't add any materials that it would take for the jump pad to being built, as we are going to spawn it in our test scene later without actually having the player building it. Now I'm going to create a texture for our jump pad and assign it to the sprite in our jump pad scene. Since the jump pad has a size of one block, the texture will be in 32 pixels. We can already spawn our jump pad in the world. We will use our test scenario we created earlier in the local folder. If you remember, we used it to spawn our gold blocks and test them. But now Since there are no gold blocks in this branch of the original project, they default to iron blocks in the level editor. We will detach the current base scenario script from our test scenario and attach a new script. It will extend the base scenario class. By removing the original script, all our settings on the test scenario node were lost. We have to reapply them. To spawn our jump pad in our script, we need to find a function that is run at the start. Our best bet will be the post-init function in the game class. We'll have access to the game class since we are working on a script that extends from the base scenario class, which in turn extends from the game class. In the post-init function, we can be sure that the world has already been initialized properly. Let's spawn our block entity by referencing its type or block entity definition. In this case, we can simply do it by loading from its file system path. As second argument, we need to pass the tile position where the jump pad should be spawned. We can figure this out from the level editor. At the origin, the cell is 0, 0. Go down 1, 2, 3, 4. Go right 1, 2, 3. And we reached 3.4 as coordinates. To run our test scenario, which won't be possible from the main menu, we need to use the game manager. Tell it to skip the main menu and drag and drop our test scenario scene into the skip to scene field in the inspector. This will cause the game manager to start the game in the test scenario scene already. Before testing the jump pad, we need to create some custom logic. Remove its default script and attach a new script. It will extend the base block entity class. I'm adding an area to the top of the jump pad to detect the player. Here I'm making sure the collision mask of the area picks up the player collision layer. Then I'm attaching the body entered signal of that area to our script. We know the body will be of type player, so we can cast it to player. Of course, the correct class name is base player and not player. Now let's add an effect to the player. The player comes with predefined effects. One of them is the jump force effect. Effects will have a multiplier and a duration given in physics ticks. When on the jump pad, we want to multiply that jump force by 2, but have the effect only last for 1 frame. So the effect doesn't carry over if we leave the jump pad again. The issue we're running into here is that the area body entered signal only triggers once when the player steps on the jump pad. But we want his jump force to multiply while he's standing on the jump pad and not only when he enters it. That's not possible with the signal, so we'll disconnect the signal and use another method to get the overlapping state of our area and the player body. We will be checking continuously for that, so we're using the physics process method. Area get overlapping bodies will give us all bodies that are currently overlapping with the area during this frame. Again, we know it can only be a player if there's any body in there, because we set up the collision mask like that. Let's run the game. The game manager will automatically take us to our test scenario scene. This is our default jump height. When we are on the jump pad, we will jump much higher. High enough to take fall damage, actually. What isn't supposed to happen is that we can go into the jump pad. We want to jump on it and have it be solid. That is supposed to be the default setting for a base block entity. And we will check our jump pad static body to see if the collision layer is applied correctly. Solid block entity is the correct setting. No collision block entity would be something we can go through. We seem to be running into a bug here. And after going down a rabbit hole, I figured out that it actually is a bug. Our collision shape is set to disabled, which we didn't do. It was inherited this way from the base block entity, and obviously something I missed when creating the original scene. And turning it off, our jump pad will now behave properly. Usually I would have stopped recording now, fix the bug, and get back to recording with the bug already fixed and never mention it. But I'll be taking this opportunity to show you how to report and to fix a bug in the proper way. To report the bug, we will navigate to the original online repository. Make sure you are not reporting it on your fork of the original project, since nobody will see it there. Here we are on the original project's website. Navigate to Issues and create a new issue. Add a title with a short description of the bug. And in the description field you can go into further detail. I won't be doing this right now. You can even post screenshots or link to the actual source code file in there. After submitting, it's there for everyone to see. Now the project maintainer, or anyone really, can propose a bug fix or start a discussion about this bug, if it really is a bug, and what would be the best approach to fix it. In this case, we'll be fixing it immediately after posting the issue. We'll be returning to our online repository. Make sure the latest branch is selected and synced with the latest branch of the original project. Create a new branch for our bug fix and call it Fix Base Block Entity Collision Shape. This should be descriptive enough. I'll be closing Godot now because we'll be switching branches from our jump pad branch to our Fix Collision Shape branch. When we are changing branches while having uncommitted changes in the branch we are working on, we will get a notice asking us if we should leave the changes on the old branch. And in this case we want to, because we don't want to work on our jump pad on the Fix Collision Shape branch. This is a clean branch of the latest stable branch of the original project. The editor was still remembering we were working on the jump pad scene and throws an error because the jump pad scene is no longer there. We fixed the disabled collision shape and now are committing this single change to our Fix Base Block Entity Collision Shape branch. Push it to our online repository, select it in our online repository, and create a pull request. I'll be giving it a title called Fixed Default Base Block Entity Collision Shape. We are even able to refer to the issue about the bug created earlier. This is the bug report issue we created in the original repository. You can see it was assigned a unique index. Using this index after a noun keyword like fixes in our description, it will automatically create a link to the bug issue. Now we create this pull request which will suggest our bug fix. When we follow the link to the original bug issue, we will see the issue has now updated to refer to this pull request we made. So the bug report automatically created a link to the bug fix because we linked the bug report in our bug fix description. Just one of the many great features that this GitHub website has. We are finished working on this branch and going to switch back to our jump pad branch. Now I did that while the editor was still opened, so when I go back to the editor, it realizes some files have changed because we changed the branch with different version of those files. We want to reload this new version from our disk. But where is our jump pad? We have switched to the jump pad branch. I'm refreshing the repository even, and I can't find the jump pad scene in our editor. What happened is, when we switched branches away from our jump pad, we still had uncommitted changes to files, which were stored in this stash. And now we need to restore the stash. To restore the last changes we made to those files. I like this GitHub desktop app because it will usually show us a big blue button when we're running into an issue, and this blue button often is the solution to the issue. And now we are back in business. Our jump pad is back. And since it was already finished, we can just commit the changes and create a pull request. Looking through the changes of all files, I realized one thing though. We made a change to the game manager, which we don't want to include. If you remember, the change in there was that we skipped the main menu and referred to our test scenario scene. This was done for local testing purposes and has nothing to do with the jump pad itself, so we don't include this file in the commit. I'm already working on a patch that will automatically resolve this in the background and you won't even notice it. You know the rest. Switch to our online repository, switch to the jump pad branch and create a pull request. Now let's create a custom scenario or game mode. Before creating our usual new branch, we want to make sure our fork of the latest branch of the original project is up to date. It tells us there have been commits to the latest branch, because I patched it. And we want to sync our latest branch with that original branch. Let's create the new branch for our custom scenario. I'll be calling it the fireworks scenario. You know the rest of the drill. We'll be greeted with a warning because the last time we closed the editor, our jump pad scene was open. Trying to restore it, the editor can find this jump pad scene in the current branch. This is nothing to worry about. Let's browse to the Game Scenarios folder. It already contains a demo scenario I created, the Iron Ingot Challenge, and 2 built-in game modes, which you can all see in this list. Free Play, Sandbox and the Iron Ingot Challenge. You already know the Free Play mode, and the Sandbox mode is pretty much the same at this point. The Iron Ingot Challenge comes with a lot of custom features and a pre-made level. Here you are tasked with making 10 iron ingots before the timer runs out. You should try it, it's fun. But let's create our own custom scenario. We will need to create a new folder in the Scenarios folder. I'm calling it Fireworks Challenge. Next, we'll have to look for the base scenario scene and create a new inherited scene from it. We already did this for our test scenario in an earlier chapter, so you should be familiar with this layout. We'll be saving this scene under our Fireworks Challenge folder, detach the built-in base scenario script, and attach our custom new script, which extends from base scenario. Then let's quickly go through some of our scenario settings. It shall have a timer, it shall have a countdown of 30 seconds, we'll give it a description, we add new settings, keep them as is, but we won't create a clearing around the spawning player. We'll create a new player loadout with one item only, which is the pickaxe. And we won't be able to cheat in this scenario. The character we'll be using in the scenario will be El Clásico, so we drag and drop them in the player scene. For some reason, our El Clásico scene looks like the ore detector in the preview image. That's Godot for you right there. I'll quickly create a level made of stone and a Godot block in the middle. We can already find our new scenario in the main menu list and play it. That's because my awesome framework lets you create the stuff rapidly. The Godot block is a custom block that triggers a firework when mined. I may or may not have recorded these sounds with my mouth. The built-in level editor is known to spam errors, but they can be ignored. To finish up, we will need our scenario to know when it has been won. We will override the onPlayerSpawned method found in the parent game script and connect to a signal that is emitted by the player when he breaks a block. The block is passed along as a parameter to the signal, so we can access it in our connected function. To determine if we won the scenario, we need to know if we broke the Godot block. The Godot block has a custom class which is called Godot block, so we can do the check like this. In this case we are lucky because we have a custom class name. Most blocks won't have a custom class. They are just instantiated from the base class block. Like the coal block, for example, as you can see here. And there just isn't a way to use the is keyword to detect some non-custom block. And I want to show you a better approach to deal with any kind of block. Let's compare against a variable called winBlock. We will create this export variable on top of our script and actually use the equals operator to compare against it. Now we can drag and drop our win block in here. In this case, the Godot block is our win block. This is a way more flexible solution. We won, but there was no firework. When a scenario switches into game over state, it will pause everything. Let's wait for 1 second before triggering the game over. And you know the rest. Commit, push, and create pull request. If you have any questions, let me know in the comments, on the project's GitHub page in the discussion section, and I'll also be hosting a custom Discord server. And remember, there are no stupid questions. I specifically set this up for beginners to contribute, so if you don't know something, just ask. Thank you and good night.